NASA's Spitzer Space Telescope wasn't designed to be an exoplanet supersleuth, but it's proving to be an amazing infrared detective tool. Spitzer has split open the light from two alien worlds, two planets outside of our solar system. The resulting data, called spectra, reveal clues about their atmospheres.
We wanted to measure the spectrum of the planet because that tells us what molecules are present in the planet's atmosphere.
Actually three different teams basically found the first real spectra of a planet around a different star. And that's a pretty big deal.
Grillmeyer, Swain, and a third team headed by Dr. Jeremy Richardson studied two planets, HD 2094-58b and HD 1897-33b, two hot Jupiters, or gas giants, that orbit close to their suns, 300 to 900 trillion miles from Earth.
Well, you've heard the analogy that looking at a planet around another star is kind of like seeing a firefly next to a searchlight. It's a very, very faint object next to something extremely bright. So how do you look at that? In order to take this spectrum, what we have to do is we have to let the planet be eclipsed by its star, so we can't see the planet anymore, and then subtract the spectra that were taken inside of eclipse from the spectra that were taken outside of eclipse, and then we're left with what the planet contributed.
Some astronomers predicted there would have been water, and to their surprise, they found no hint of it in either atmosphere. That could mean the water is hiding under a blanket of high clouds.
If the clouds are at high elevation, they may just obscure the atmosphere of the planet, the lower atmosphere, where the strong water signature might exist. I think it's premature to say.
Richardson's team, however, did spot something else: silicates.
There was a feature that we saw in the spectrum that is probably due to silicate emission. And silicates are like molecules that have silicon and oxygen and typically some other metal in them. And what that means is that there's likely a cloud that's pretty high in the atmosphere that could be made of these silicate grains, basically dust grains.
Spitzer astronomers hope to study the two planets more in the future and to use this technique on a handful of other transiting planets that orbit stars outside of our solar system.
I think this will ultimately be one of the most important legacies of the Spitzer Space Telescope. Unanticipated as it was before launch, I think it'll become extremely important in the future.
This is a stepping stone to eventually studying signs of life on worlds where life could exist, the habitable worlds which we're hoping to discover in the near future.
A step perhaps to answer the question, is there another Earth out there?